there's an important rule that comes out of this notion of the first derivative determining when a function is increasing and decreasing. I'm going to try to draw a picture to explain this a little bit more. So let's say we have a location where the first derivative is 0. We have a critical point. Okay, we'll call it C, critical point C, and at C, f prime of C is 0. That's what makes it a critical point. Or we also know it could be non-existent there. The derivative could be non-existent, but I'm going to pick the case, the more common case that we have in the text, where f prime of C is 0, not undefined. So if we knew simultaneously, besides the fact that f prime of C is 0, which means it has a horizontal tangent there, right? Horizontal tangent happening right there. If I knew simultaneously that f prime of x was positive on this side of C, right? Which would mean what? Well, if f prime of x is positive, that means the function is increasing, right? So f is increasing on the left, in this case, of C. So I'll just draw something that looks like it's increasing here. Right? Increasing, getting higher towards this location, right? Has some positive tangent slopes, and eventually the tangent tapers off to horizontal here right at C, which is what's giving us this derivative of 0 right there at C. If simultaneously, besides that, I also knew that on the right-hand side, f prime of x was negative to the right of C, that would mean that f was decreasing. Okay. So I'll just draw now a picture that looks like it's decreasing. So from here, after the tangent line goes horizontal, it will start to decline and become negative in slope, and therefore it's now turning the points, in a sense, downwards, right, away from the C location. So we have to go decreasing here for our function. It'll look something like that. Okay. So what have we found? We have found, right, that if this is the case, we have a local maximum. Okay. So you can play the same sort of game again with the opposite result. You had a location C, there it is, and you knew that f prime of C was 0. So again, you have a horizontal tangent right there at C. But simultaneously, if you knew that f prime of x was negative to the left of this location, you would know the function f was decreasing towards this location. So here it is, sweeping down towards this location, right? Going downwards towards it, because the function is going downwards thanks to the derivative being negative. And then if also f prime of x was positive on the right of C, and you know that f is increasing right after this location, right after the derivative tapers off to 0, it then begins to increase and become positive, which now directs the next points on the function upwards, in a sense, in an increasing manner. You know that you would have found a local minimum. So that is the basic geometry, the basic graphical interpretation of what's called the first derivative test, which is ubiquitous throughout the rest of this chapter now. It comes up quite often. First derivative test is basically this. If C is the critical value, of the function, which means what? It either makes the first derivative 0 or undefined, and simultaneously f prime of x changes sign at C, then there must be a relative extremum at C. Now that relative extremum could be a max or a min. Then there must, oops, I looked at a word, sorry. There must be a relative extremum at x equals C. All right, and as we see in the picture here, right, both pictures, we have critical value here, and the derivative changed sign from positive to negative, or negative to positive, and it produced some sort of relative extremum in the first case. I'm not going to write it all out down here, but you can just tell from the picture, and you should think about it. Instead of memorizing a verbal rule for this, you should just think about what's going on with the picture in your mind, that if the derivative goes from positive to negative, right, the function must have gone from up to down, and therefore you must have gone through a relative max. If the first derivative goes from negative to positive, the function must have gone from downwards to upwards, producing a relative minimum. Right? Just think about it geometrically. Don't bother to memorize a verbal rule. It'll just be more confusing.